السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. إن شاء الله today we will finish the adversarial search session, probably even before the middle of the lecture. Inshallah, we'll start a completely new session today also, inshallah. The last part of the adversarial search session is talking about other game types than the types that we saw before. Actually, we saw mostly the minimax and the expectimax when the players, and usually we talked about two players. Okay, there are other types, of course. The first one is mixed layer types, and the classical example here is the backgammon, الطاولة, or طاولة. In that game, you can assume that you play your turn, and then there is a roll of dice, right? And based on that, the other player is making a move, or is taking his turn. So you can assume that there is a random agent in between. So if you think about the levels of the search tree, so that level is your level as an agent. Then there is a chance nodes, chance level, where you roll a die, so you don't know what exactly will the die will get. Of course, among different possibilities here. So each possibility will have its own probability, and then based on that, the other agent will have his or her action or move. Okay, we call this expecti minimax. Okay, expecti minimax. Why is that? Because we have two agents. One is maximizing and one is minimizing, but there is a random agent in between. So there is a chance node level in between. So that agent is trying to maximize. This chance node, of course, is getting the expectation, or is averaging, weighted average, and this agent is trying to minimize. Okay, so this is how the search tree will be designed. It has to be designed that way, and of course each agent has its turn, and each node computes the combination of its children based on whether it's max node, min node, or chance node. As I said, backgammon is the classical example. The number of legal moves every time is on average is about 20 legal moves. The point here is that as depth increases, the probability of reaching a given search node shrinks. Why is that? Because there is the chance node. The chance node is the branching is high, is large. Each branch has a probability. Of course, the sum has to be 1. These probabilities is not a big probabilities. As we get even deeper in the tree, the probabilities, the total probabilities for getting to the terminal nodes or deeper nodes is of course decreasing. Okay, remember that you will have to get the total probability, you have to multiply the probabilities along the path. Multiplying the probabilities, of course, will decrease the probability at the end. That means that it's not very useful to actually build the entire tree or to go very deep. So limiting the depth of the search using depth limited search will not be very harmful here. Actually, will be good enough. And with that, backgammon was the first ever game in which AI-based agent was the world champion. Okay, it wasn't very hard actually to beat the best player. I don't know exactly, I don't remember now the time, but it was actually the first game ever that was declared for AI to be the world champion. The agent at the time was a mix of depth to search, good evaluation function. Of course, when you limit the depth of the tree, you'll have to use evaluation functions. Okay, so for that there was a good evaluation function that was used. Reinforcement learning also was used. Inshallah, I hope that we will have time in that course to cover reinforcement learning. If not, then it might be covered in any machine learning course that inshallah you will take in the future. And that was actually enough for AI-based agent to be the world champion in that game. Any question up to this point? Yes, Saad. What do you mean? I don't see the analogy here. Yes. Yes, but there is no randomness here, right? In Pac-Man so far. Yani in the example that you mentioned, there's no randomness, right? Yeah. If there is randomness, of course, it might be expect max or mixed like that. It depends on the rules. Okay. Okay. Any other questions? Okay, the next type that we will talk about, actually the last type, is called multi-agent games. Okay, remember so far we were assuming zero-sum game where the sum of the utilities for players is zero. Okay, now that's not always the case. If we have multiple players, each one might have its own utility. Okay, so for example, if you look at the search tree that we are having here, so you will see that at every terminal node, so in that search tree we have three players. We have the red player, blue player, and green player, and each one has its own his own turn. And assuming that these are the terminal nodes, we will have the utility for each player. So one is the utility of the first one is the utility of the red player, second is for the blue player, and the third is for the green player, and so on for every terminal node. Now, if that's the case when we have three players, why didn't we have two utility values when we have two players game or when we have zero-sum game? The reason is that it was a zero-sum game, and that means that the utility for one is the negative utility of the other. Okay, so it doesn't make any sense, or it won't be useful to keep both, to keep track of both utilities. One of them was sufficient. Okay, because the other is just the negative of the other of the first one. So that was the case when we had the zero-sum game. But in this case, we have to keep track of the three utilities. Okay, because the sum of them is not zero. Each player is trying to maximize his own utility. Okay, and that's why in that game, unusually, because usually we had min and max, or min or max and chance. Here we have all max. Okay, and the reason is that each player is trying to maximize his own utility. Okay, so at some point they might be playing against each other, of course, just by chance, not because of any coordination, and the other points they might look like playing collaboratively. Okay, or some of them. For this specific example, if we want to get the value of the game, okay, if we want to compute the value of the game here, how would we compute it? Okay, as usual, we go bottom up. So for this player, for this level, this is the turn of the green player. So the green player will try to maximize his own utility. So the utility for the green player here is 6, here it's 2, so the utility for the green player will be 6. Now, we cannot just say 6 and that's it. We have to move around or take into consideration the utilities of all players. So now the utility will be 166, which is the whole tuple here. Okay, so at that point, although it was chosen by the green player, but of course there is also a utility for each of the other players. So that will be now 166. This one, because we are maximizing the green again, this is 2, this is 1, so that will be the left branch, so that will be 6, 1, 2. For that one, 7 here, 2 here, so that will be 5, 1, 7. And for this one, it will be 5, 2, 5. Now, when we get to the second level, to the blue level, the blue player will maximize his own utility. Okay, the blue here is the second number, so this is 6, this is 1, so the value here will be 166 because he will choose to go left here. Okay, so the value will be 166 here. Here it will be we have 2 here, we have 1 here, so that will be 5, 2, 5. Now the turn of the red player. So the red player will maximize his own utility, which is the first number, so he will choose 5, 2, 5. So if that game is played, and assuming that this is the whole game, then the red will go right, blue will go right, red will also go right. Okay, so that's how the game will be played if this is the search tree. Okay, and if you look at these values, you will see that sometimes you will think that two players are playing in favor of each other just by chance, but actually they are completely independent. Each one is trying to maximize his own utility. Or sometimes you will find that they look like playing against each other. Okay, again, that can happen at some points in time, and other points in time they might look like friends. But the point here is that each player is trying to maximize his own utility. Any question about this? So we saw in the previous slides, expect the minimax. Okay, here is everything is max. Okay, but everyone is maximizing his own utility. Yes, Faisal. Okay, the rules of the game here is to maximize your own utility regardless of the others. Okay, so there is no benefit from getting the opponents losing points in that game. Okay, you are just trying to get the best you can. It's like a competition. It's like a race. Okay, so if you are doing the race ethically, you will not step into the other's feet. Okay, so you just go into your lane and try to get to the finishing line. That's exactly the case here. Okay. Any other questions? Okay, if there is no question, then congratulations, we are done with the fifth session. And now we will switch to a completely new session. So give me a second to navigate to the other one. So we are done with 5 sessions. We started with the introduction, then the general search algorithms, then constraint satisfaction problems, then local search, then adversarial search. Okay, so all of that was about search-based agents. Now we'll completely switch gears and talk about knowledge-based agents. Okay, knowledge-based agents. If you have any problems with whatever we discussed earlier, don't worry, that will not affect anything about this part, which is about knowledge-based agents. So from the name, knowledge-based agents, that means that we will talk about knowledge. What is knowledge? Knowledge are the things that we know about the world. Okay. Things like I live in Doha. I work as a associate professor. The sky is blue. Okay, all of these are pieces of knowledge to me. Okay, or about me, or about the world. These things that we know about the world, will affect, of course, the decisions that I will make in the future. Right? Whatever we know, hopefully, you can ignore them, but hopefully if you are a rational agent, okay, if you are acting rationally, then of course you should make use of the knowledge that you know. That will lead us to what we call knowledge-based agents. So in knowledge-based agents, or knowledge-based agents are powered by the intelligence about how to reason over the knowledge that the agent has. Okay, how to use the knowledge that we know now to discover new knowledge and to make good decisions over time. Of course, reasoning over the knowledge that we know will allow us to discover new knowledge. We can add this new knowledge to the knowledge base that we will keep track of, and that will make our decisions even better in the future. So that will lead us to talk about knowledge bases. I think you are familiar with databases, right? In databases, usually we just put raw data. We just put maybe measurements, okay, just numbers or names, okay. When it gets to data that has meaning, this is what we actually call knowledge. Okay, so the knowledge, or the knowledge, the knowledge that we will talk about when we talk about knowledge-based agents is represented in what we call knowledge base. So the knowledge base actually is a very major component of the knowledge-based agent. That's actually the tool that the agent will use to navigate into the world or to make decisions in the world. Formally, the knowledge base is a set of sentences written in a formal language. Okay, so we use the word sentences here compared to the word maybe records in databases. Okay, so here we use sentences, and sentences here means a way of representation in a formal language, in a specific language. This language is called the knowledge representation language. This is the language that we use to represent the knowledge that we know. Okay, and when we use it to represent the knowledge, we will represent the knowledge into sentences. Okay, and the sentences will represent actually assertions or facts about the world that we are interested in. To interact with the knowledge base, we will have to use for now, we'll have to use two operations. The first one is called tell. The tell operation adds new sentences to the knowledge base. So now today I know some new things about my environment, I will add it to the knowledge base. Or while I'm thinking about what action I should do, I discovered new sentences, so I will add to the knowledge base. So the tell operation will add something to the knowledge base. And that's actually how we also think about the world, right? As time goes, hopefully we learn more things. We add them to our knowledge base, which is stored mainly in our brain or maybe in books or whatever. Okay, so we add what we know to what we add things that we discover to the knowledge base or what we know. The other operation is ask, is about querying the knowledge base about what is known and asking what action to perform. So the first one was just adding new knowledge to the knowledge base. Ask operation is trying to get what action to do now based on the knowledge that we know so far. Okay, so these are the two main operations. Tell, adding to the knowledge base. Ask will query the knowledge base to know what action is the best to do now. And both operations may involve inference. What do you mean by inference? Discovering new sentences, new knowledge from the existing knowledge. Okay, from analyzing, and we'll see that inshallah probably today, and of course during the session. This session actually will take us maybe between 2 or 3 weeks. So we'll see how that will actually work. But for now, both operations, tell and ask, might involve extracting or discovering new knowledge that, or new sentences that we will add to the knowledge base, and now we can make actions or decisions based on that. Questions by Mahmoud. Yes, yes, ask the query the knowledge base. Yes. Did I answer your question? Okay. Any other questions? Okay, let's move on. Now here is a very simple knowledge-based agent. Okay, that's a very simple or abstract way of looking at a knowledge-based agent. The knowledge-based agent has to keep track of a knowledge base, okay, that is updated, of course, over time, and also the time, okay, a counter that indicates the time. And it, let me change this, it will take an input from the environment. We call it percept. So that percept is the input from the environment. Okay, maybe knowing that today is Thursday. That's something that we got from the environment. For myself, knowing that today is Thursday, or maybe an agent that is cleaning that room, it might get a sense or an input that says that there is an object 1 meter ahead of me, or 30 centimeters ahead of me. Okay, so that's an input from the environment or from the world. Based on that input, and based on the knowledge that we know so far, we might discover new knowledge, and we take an action based on that. Okay, so that simple agent, the first thing we'll do is to tell the knowledge base that I got that input at that time. So I'll have to make a sentence. So this function make percept sentence will create a sentence in the formal language that we use to add to the knowledge base, or to present the knowledge. The sentence will say that we got this percept at that time, because that's now a knowledge that we know, right? That will be added to the knowledge base, and based on that we can get a good action. Then we will get an action based on what we know, and for that we'll have to create also a sentence to ask the knowledge base. Okay, so something to query from the knowledge base, and based on that we'll get an action. Okay, of course this is a very abstract way. We'll talk about details inshallah later, but in the second step, so the first step is to add what we sensed from the environment to the knowledge base. The second step is to ask the knowledge base to what to do now. Then we'll tell the knowledge base that we will do that now. Okay, so we'll have to create a sentence for making action, given the action and the time, so that we will do that action, or we are doing that action at that time. We add it to the knowledge base, and then we increment the time. Okay, of course, finally we will return the action that we made. So that's a very simple knowledge-based agent that is driven by percept. So it will get something from the environment, act upon it, save it to the database, or add it to the database, and then get a new percept, and so on. Okay, so that's how the agent will work. Any question about this? Okay, that means that the agent has some responsibilities. The agent has, of course, in terms of implementation now, the agent has to represent states and list of actions. It has to incorporate new percepts, so it has to make sure that it gets new input from the environment, and the input might be of different types. It has to update the representation of the world. It has to update the knowledge base internally. It has to also sometimes to discover new things about the world and add them to the database, not the database, to the knowledge base. And it also has sometimes to discover what good actions to do. Okay, so these are the whole a list of things that an agent in reality has to keep track of. You can think also of the agent at two levels. There is the knowledge level and there is an implementation level. The knowledge level is including the knowledge base that we have. Okay, and the knowledge base here will be domain specific. Now, for example, if I want to build an agent that has some knowledge about health. Okay, the knowledge base will have something like how many calories for each food item, whether this meal is healthy or not, things like that. Okay, what is the normal temperature, body temperature, things like that. Okay, so that will be domain specific. So always the knowledge base is very domain specific. Okay, it has knowledge about specific domain. The inference engine, or the level of inference, will have the algorithms that will reason over the knowledge base. These algorithms don't have to be domain specific. Actually, they will be domain independent algorithms. It's exactly like what we did in search algorithms. The search algorithms were abstract. Okay, I mean, they were independent of the domain. They can be used with Backgammon, they can be used with any other agent, right? So the algorithms themselves are domain independent. They include, of course, data structures and the strategies that we will discuss. But the knowledge base has to be domain specific. Okay, so we have these two layers, and we can look at the agents from these two perspectives. The knowledge level, which is what we know, and it's domain specific, and that's independent from how the agent itself is implemented. And at the implementation level, we have the domain independent algorithms and data structures. Any question up to this point? Because now we'll turn to a specific example, just to think about how knowledge-based agents will work. Any questions so far? Everything is clear? Okay, thanks Faisal. Thanks Yusuf. Mahmoud. Okay, Mahmoud, you have a quota of questions. You are about to get all of them now. Go ahead. Good question. You can think of it that way. It's not the search algorithm. It's something that we want to know now, based on what we know already, or something that we want to query. For example, let me give you an example. General example again. Is this sentence true or false? Okay. So that's a query. How can we know it's true or false? We'll have to reason over the knowledge base that we have. Okay. Did I answer your question? Okay. Okay, it seems like I didn't answer the question then. It's not, we are not searching here, we are inferring new things. We are reasoning over the knowledge base that we have. It's different from search. Search, you have a specific goal that you want to reach, right? And you are trying to reach that goal. But here you are trying to reason over the knowledge that you have, so that you can make actions. Okay, maybe it will be more clear, inshallah, over time. But it's not exactly like search. It's different. Okay. Yani you might not find exactly what. Yani for the example that I mentioned, is this sentence true or false? You might not exactly find this sentence in the knowledge base. Okay, to say this is true, or even if that sentence explicitly is not in the knowledge base, that doesn't mean that it's false. Okay, you have to reason over what you know, so that you can say whether this is true or false, or you don't know. Okay, yani the knowledge base might not be sufficient for you to say whether this is true or false. So that's different from search algorithms. Okay, any other questions? Okay, then let's see the example. I don't know if maybe some of you know this already, but it's anyway. This is like the Pac-Man game, but for knowledge-based agents. Okay, so that will be the running example that we'll use, inshallah, in this session. This is called the Oneplus wallet. So what is the Oneplus wallet? The Oneplus wallet is a game where there is an agent, okay, and the agent is navigating a cave, okay. So this whole thing is a cave, and that cave has 16 rooms, 4 by 4. Each square here is representing one room, and the agent is trying to navigate through the cave so that it can reach the gold. Okay, the gold piece. So the gold is in one of the rooms, but the agent doesn't know, of course, in advance where the gold is. So he's trying to explore the wallet in order to reach to the gold and to get it back to the starting room so that he can climb out of the cave from that room. Okay, now inside one of the rooms of the cave that we don't know where, there is a specific creature or animal called Oneplus. Okay, and if you means the agent here, if you stepped into a room where the Oneplus is, you will be killed. Okay, so that's the rule of the game. Now that's not everything. Whenever you are in a room that is a neighbor to the Oneplus, you will sense a smell, a bad smell called stench. Okay, so there is a stench sensor that will tell you, yes, there is a stench in that room. That means that in one of the neighboring rooms, there is the Oneplus is there. Okay, it's just horizontally and vertically. It's not diagonally. Okay, now besides the Oneplus, there are also some rooms where there are what we call pits. Pits are holes, actually bottomless holes. That means that if you stepped into a room where the pit is, you will also be killed. Okay, so you will have to avoid being in a room where the Oneplus is, because you will be killed, and also where a pit is, because you will be also killed. Okay, now when you are in a room that is next to a pit, you will smell a smell called breeze. Okay, so here, if you look at the example here, there is a breeze 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 here, right? Because all of these rooms are next to this pit room. Also, there is a stench here because the Oneplus is here. There's stench here, there's stench here, but there's no stench here. Okay, because as we said, it's not diagonal. Again, also there is no breeze here because it's not diagonal. Okay, so it's just to the horizontal and vertical neighbors of the pit. You will sense a breeze, and to the Oneplus you will sense stench. Okay. Also, you have one arrow by which you can kill the Oneplus. Okay. How can you kill the Oneplus? You face towards the Oneplus, and you shoot the arrow. When you shoot the arrow while you are facing the Oneplus will be killed, and you will hear a scream at that time. When you hear a scream, you will know that the Oneplus was killed, or the arrow actually reached the Oneplus. But you have only one arrow, so you can use only one arrow while you are exploring the game. What else? And you have to face, of course, the Oneplus when you shoot it. Otherwise, it will not kill the Oneplus. So if we are facing right now, okay, and the agent shoot the arrow, it will not kill, of course, the Oneplus. It has to turn left and then shoot the Oneplus. Rules of the game also, you will get -1 for every step. This is very similar to Backgammon. You will lose 10 points if you use the arrow. Okay. You will get 1,000 points if you found the gold, and you will lose 1,000 points if you are killed. Okay, so of course you want eventually to maximize your score at the end of the game. If you are killed, of course, that's the end of the game. Or if you are climbed out of the cave, that's also the end of the game. I think that's it. The sensors again are, we have 5 sensors. We talked about stench, breeze, glitter. You will find glitter in the room where the gold is. So if you stepped in a room where the gold is, you will see a glitter. Okay, or you sense a glitter. That means that the gold is here. Pump is an input signal. If you stepped into a wall. Okay, there are of course walls around surrounding you, the cave. So if you stepped into a wall, then you will get a pump. Okay, you know that there is a wall here. And we talked about scream. Scream, you will get that if the arrow killed the Oneplus. The actuators or the actions: left turn, right turn, forward, grabbing the gold, release the gold, shoot is shooting the arrow, and climb is climbing out of the cave. Okay, any question about the Oneplus wallet? Is the game clear now? Any questions? Okay. Now some characteristics of the Oneplus wallet. Is it fully observable? Of course not, because the agent doesn't know what is in the rooms that he didn't explore yet. Okay, so he doesn't have the full picture. It's only through the local perception. Okay, is it deterministic? Yes, there is no randomness here. The outcomes are exactly specified. Is it sequential? Yes, we are making sequential actions one by one. Is it static? Yes, Oneplus and pits don't move. Okay, so if they are started, of course the locations are determined before the game starts, and once they are determined, they are fixed, they won't change. So the Oneplus actually doesn't move, alhamdulillah. Okay, it's static from that sense, and also pits don't move, so they are static. Discrete, of course, yes, because we have discrete actions and discrete also inputs. Is it single agent? That might be a bit confusing because we see that we have two players here, the agent and the Oneplus, but actually the Oneplus is not an agent because he's not playing against us. He's just static. He's just a nice animal. He's just waiting for you to kill you, of course, but he's waiting inside the room statically, so it's not doing anything against you. Okay, so that's actually a single agent. It's not taking any actions. Okay, so these are the characteristics. Then let's now take an exploration example through the Oneplus wallet and see why an agent in this case is a knowledge-based agent. Okay. Of course, first the rules of the game has to be kept in mind. Okay, so have to think about how to represent these rules into the knowledge base. Not today, probably inshallah next lecture, but keep in mind that the rules are in the knowledge base now. Now, if we start in this room, okay, so we are starting in this room, okay, and we assume that we got these 5 percepts. Okay, these 5 percepts are in that order: stench, breeze, glitter, pump, scream. Okay, so since there is no stench and there is no breeze, that means that there is no pit here, and there is no pit here or there, and there's no also Oneplus here or there, right? So that's why we wrote here okay. Okay means this room is safe, we can step into it, and this room also is safe since there's no pit nor Oneplus. Okay, so we know how did we know that? We know that because we didn't get any because of the values of the sensors here. Okay, so we didn't get stench, we didn't get breeze, so we inferred that this room is safe and this room is safe. Okay, so now we should add that to our knowledge base if we are keeping track of the agent. Now, what action I should take? It's either go up or go right. Now the agent decided just randomly to go up. Okay, take one of these 2 actions. He went up. Now, when he went up, because that's safe, right? So that's not a problem. When he went up, now he got new percepts. So he got none in terms of stench. So there's no stench, but he got breeze. Okay, so no stench. okay, give me a second, Faisal. I didn't finish yet. Okay here means there's no Oneplus, there's no pit in both. Okay, so okay means safe. Okay, now it's still okay because because these rooms are safe already. I don't know where the contradiction is, Faisal. What's the problem now? Yes, that's why we have B here. Okay, we didn't finish yet. Okay, but having a breeze here doesn't mean that the Oneplus is here. It means that the Oneplus is here, or sorry, it's not Oneplus. Sorry, breeze means a pit. Okay, so breeze means that there is a pit here or here, but there is no Oneplus here and there is no Oneplus here because we didn't get stench. Do you still have a problem, Faisal? It's not a new problem. We moved up and we get new percepts. Yani, this is the previous one. In the previous one, we said that this is okay. Okay means he is safe, but we didn't get the input from that room because we didn't step yet into these rooms. But we know that there is no pit, there is no Oneplus. Okay, and still we know that there's nothing new here. It's the same problem, but we stepped into that room. Now, when we step into a room, we get a new input, new smells, right? Okay, so let's continue from that. Now that we know there is a breeze here, we said that there is a pit here or here, right? And we didn't get any stench. That means that there's no Oneplus here, there's no Oneplus here. Okay, type. Anything else we can infer? So now this is a new thing that we should add to the knowledge base, by the way, that there is a pit here or there, because of course we will use that later in our reasoning. Anything else? Type. What action the agent should take now? Faisal, raise hand, please, Faisal. Okay. Yusuf. Wa alaikum salam. Yeah, why shouldn't we go here or there? Yes, it will be risky, right? Because we might have a pit. Okay, so this is the one that is safe, so we can go here and maybe get new inputs that will help us, right? Okay, so that's actually what the agent will do. Now we have pits here or there, so the agent decided to go to this room. Of course, that's not one step. It has to turn around and then move again. Okay, but that's we will not get anything because we already explored these rooms. So here, I mean, nothing new. Here now, the new inputs are like that. Okay, so we got a stench, which means that Oneplus is somewhere. So we said earlier that Oneplus cannot be here and Oneplus cannot be here, right? So because of the previous breach here and absence of a stench. So having a stench here means that the Oneplus is somewhere around. We are sure that the Oneplus is not here. We are sure that the Oneplus is not here. So the Oneplus has to be here. So now we determine, of course, this is because of the reasoning that the agent can do on the knowledge base. So the Oneplus has to be here. So now we know that this is the Oneplus. Okay? This is where the Oneplus is. So we should not step into that room ever. Otherwise, we will be killed. What else we can infer from that input? Anyone? Any thoughts? Yusuf? We can kill it. We can kill it, but But why do we need to kill it now? Yani there's no reason for killing it, because killing it means we will lose 10 points. Okay, but if we need later, we might need to kill it, but maybe we will get around it and get the gold without shooting the arrow. Okay. Go ahead, Yusuf. Go ahead, Yusuf. Yusuf. Why? How did you know? Yes, very good. Yes, so there's no breeze here. Okay, that means that there is no pit here. Okay, so that means that this is not true, and it means, because we are sure that it is here or there, right? So we have to have pit here. So the pit, actually there is a pit here. So that's what we can add now to the knowledge base. Thanks, Mahmoud. So now we can add two things. So okay, let me finish this and then I will take your question. So now we know that the Oneplus is here, for sure, and for sure also we know that a pit is here. Okay, Mahmoud. Yusuf or Mahmoud, who has a question? Yusuf, go ahead. Okay, that's what we will study. That's what we will show how we do using the knowledge base. Okay, and but I'm in this example I'm trying to motivate the things that the agent will need to do. Okay, we'll have to have the knowledge base that has the rules of the game initially. Whenever we discover something, we add it to the knowledge base, like that there is a pit here or there. Okay, and then whenever we get percepts, we also add them, and we discover new sentences. Yeah. Okay, and based on that we take the next action. Now, what should be the next action? Okay, Faisal. So we should move to that room. Yes, yes, and sense again. Okay, now we move to that room. Sorry, that means that this is safe now. Okay, now we move to that room, and when we move to that room, we didn't get any smells. Okay, what does that mean? That means that there is no pit here. That means that this is okay, and this is okay. Right? These two rooms are safe. Otherwise, we would have smelled anything here in that room. Okay, so there's no pit here, and there's, of course, Oneplus is not here also. There's no pit here, and there's no pit here. So we can move to this room or to that room. The agent actually chose to move to that room, and in that room he got stench, breeze, glitter. Okay, of course stench, because we have the Oneplus here. Okay, so that's expected. Breeze here means that there is somewhere near us there is a pit. So there is a pit here. Now we know that a pit might be here or a pit might be here. Okay, and the glitter tells us that there is a gold here. Okay, so the next action should be to grab the gold, of course, and probably go back on the safe path here to get out of the cave and win the game. Okay, so that was just an example to show you the Oneplus, to get you familiar with the Oneplus world, and get you familiar also with the possible actions, with the possible sensors that we have, and how a knowledge base can help us. Okay, of course we didn't show how it will be represented yet. Inshallah, we'll show that next time. But now you know that there are things that we have to keep in mind and make reasoning over, so that we can get informed or good actions for the future. Any questions before we stop? Okay, we'll have to, inshallah, to stop here and talk to you, inshallah, on Sunday. I finished the grades. I finished grading the midterm, and the grades are posted. So if you didn't notice that, you can now go and check your grade. Actually, overall, the grades are good. Okay, there are many good grades actually. Some grades are not as good as I expected. So you need to think seriously about that. The exam was not hard, was really average, and you cannot say that it was hard, you cannot say it's completely easy, but it was an average exam. So if you got really bad grade, then you have to seriously consider what you are doing in this course. If you need any help from my side, please let me know, email me, and we can talk about how we can make things better, inshallah. Okay. And also, if you need to see your paper, let me know, because you have to be on campus to see your paper. So we'll have to schedule that, inshallah, sometime next week. Talk to you, inshallah, on Sunday. Assalamu alaikum wa rahmatullahi wa barakatuh. The office hour is on the blackboard. You can check it. I think it's for your section is on Tuesday. But if it's not convenient for you, you can schedule another time. Okay, you're welcome. Any other questions? Okay, see you inshallah next week. Assalamu alaikum.